Hello friends, my name is AJ and welcome to my channel. This is part 2 of the in-depth review for Unit 4 of AP Computer Science on iteration. In this particular video, I'll be going over the practice test that I created for you. This particular practice test that I made is 14 questions, multiple choice, and an FRQ. And will definitely be very helpful in case you're preparing for an in-class test or the AP exam. The actual link to this practice test is in the description below, so I definitely recommend downloading it and trying it out before watching the video and checking, and because in this particular video I'll be doing an in-depth explanation of each of the questions and the correct answer for each question. Alright, without further ado, let's get started with number 1. Alright, so the number 1 question says, which of the following are true about while loops? Right? So 1, while loops change the flow of control by repeating a set of statements 0 or more times until a condition is met. This is true because it's repeating. It can repeat 0 or more times depending on the actual condition and whether or not that condition is initially true or not. The second part, a while loop is an infinite loop when the Boolean expression always evaluates to true. The key word here is always evaluates to true. If the Boolean expression that is part of the while loop is always true, then it is going to be an infinite loop because the loop will never end. It's just going to keep repeating and repeating and repeating forever. So that is also true. And then 3, if the Boolean expression evaluates to false initially, the loop body is not executed at all. This is also true because remember, if the condition is not true initially, the loop will repeat 0 times, meaning it's not going to run. So the correct answer for this is going to be 1, 2, and 3. Okay? Now number 2, which of the following is the output of the code below? So here I have an integer 1. So I'll write out my output here on the side. So I originally have the value of 1, and while a is less than 10, I print out a, so 1, and then I have a space, and then I add 1 to a, so now this will be 2. 2 is less than 10, so I print that out. I add a space, and now I add 1 to this. It's 3. 3 is less than 10, so I print out 3 and a space, and I add 1 to a. Now it is 4. 4 is less than 10. That is true. So I print out 4. I add a space. And then I add 1 to a. Now a is 5. Is 5 less than 10? It is. So I print out 5. And then I print out a space. And then I add 1 to a is 6. I print out 6 because 6 is less than 10. Then I have a space, right? Then I add 1 to a is 7. Is 7 less than 10? It is, so I print it out, and I do a space. Then I add 1 to a 8 to make it 8. 8 is less than 10, so I print out 8, and then there's a space. And then I add 1 to a. A is less than 9, so I print out 9. And then I add a space, and then I add 1 to a to make 10. 10 is not less than 10, therefore my loop ends at this point. So the output for this loop is going to be A, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if you saw what I did there, that was possibly painfully repetitive. However, again, it is very important to, especially these type of questions, and especially if you need the practice and aren't as comfortable, you should do what I did, just slow it down and just kind of, answer. And just each time the loop iterates, just run it. And as you saw here, every time A increased, I added it and I sounded it out. You can sound it out in your head, obviously, if you're on a test because you can't speak out loud. But, I said that, okay, is 2 less than 10? It is. So then print it out, add a space, and then add 1 to A. Just keep repeating that process in your head and kind of doing it on here, and that will ensure that you actually get your answers correct because you're checking your work as you're going, and you're also slowing down so you make less careless mistakes. All right. So now we have number 3. Which of the following is the output of the code below? So I have Boolean A equals true. And then I have while A. I have B equals 1. and I have C equals 0. And then I have while A. So while A is true, if B is less than 10, right, or greater than 10, then A is equal to false. So right now, B is not greater than 10, so this does not happen. So then I add 1 to C, and I subtract 1 from B. Then my loop continues. Is B greater than 10? It's not. So therefore, A does not change, and I add 1 to C, and I subtract 1 from B. Is negative 1 greater than 10? It is not. So therefore, I will add 1 to C, minus 1 here. Then I do it again. Is negative 2 greater than 10? It's not. So then C will become 4. This will become negative 3. Are you starting to see the problem? Right? My condition to end my loop is that B has to be greater than 10. But because here, I just keep lowering B, I'm actually getting farther from my goal than closer to my goal. And there's no case in here where I'll actually be able to increase B. Therefore, when I am running this loop, it's going to keep repeating over and over and over and over again and until there is no end. So therefore, out of the answer choices of 8, 9, 10, 11, the correct answer will be this is an infinite loop. Okay? All right, now we go to number 4, and this is an example of a nested loop. This time it is a nested while loop. So I have counter variables A, and I have counter variable B. I say while. All right, so my first iteration of this loop, A is less than 3. Is that true? It is true. So then the first thing inside of my loop is a while loop here. Fun, right? So I have, is B less than 4? Right? Well, right now, my B is equal to 0. So because that's true, I print out one single asterisk, right? And then I add 1 to B, so my B becomes 1. And then my loop repeats, right? Is 1 less than 4? It is. So I do this, and then I add 1. Is 2 less than 4? It is. So then I add 1. Is 3 less than 4? It is. So then I add 1. Is 4 less than 4? No, it's not. So therefore, that is where my loop ends. And so now I get to my next statement. B equals 0. So now all of this goes away and B is back to 0. And now I add 1 to A. So now my A is 1. Right? Now, is 1 less than 3? It is. So now I have to repeat everything inside of my while loop again. So while B is less than 4, well, 0 is less than 4, right? So I print out this. I add 1 to B. 2 is less than, 1 is less than 4. 2 is less than 4, right? 3 is less than 4. And 4 is less than 4, right? Just like that. So now I have a total of, sorry, I did one extra here. I now have a total of 8 asterisks. And now the last time I do my loop again, right, A is going to change from being a value of 1 to being a value of 2, and B is going to be equal to 0. So now, because 2 is less than 3, I repeat the inner loop and stuff again. And I know that that is going to print out, because I've already done it now so many times, it's going to print out 1, 2, 3, 4 asterisks, right? And then the last part, B is equal to 0, and then my value here of A increases from 2 to 3. And then because 3 is equal to 3 and not less than 3, this now stops running and the loop is done. So now looking at my output, there are going to be 12 asterisks. So whatever answer choice has 12 is what I'm going to choose. And I believe that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is going to be C. And C is the correct answer. All right, so now we go to questions 5 and 6. And questions 5 and 6, both refer to the same block of code. And this one is also a nested while loop. Hooray. We all love nested while. We all love nested loops, right? All right. So this is an interesting thing. And in fact, this is very similarly based onto the loop that is above. But here I have A, and then my condition is that A is less than end A range. And then B is less than end B range, right? And then here inside I print out an asterisk, I add 1 to B, and then I create a new line, I set B to 0, and I add to A. So what's going to be, let's think about, what our actual loop might, what was it actually going to produce? And the best way that I feel of actually looking at this is let's read both questions. The first question says, which of the following best describes the output from the code above? So I have, there is a table of asterisks outputted with the number of rows equal to the A range variable and the number of columns equal to the B range variable. And then I have, there's a table where it is opposite. So rows is B range and columns is A range. Then I have one less, and then, one less than this. So I'm pretty much have multiple choices for this particular question. And then I have a question, which of the following best describes the output from the code above if end A range is equal to 5 and end B range is equal to 4? So in this case, I actually want to answer question 6 first. The reason why I want to answer, or I may want to answer 6 first, is because if I'm not sure about this question here, right, I can use question 6 to actually answer the previous question, because then I can observe what actually happens, right? So let's say I said end A range equal to 5, and end B range is equal to 4, just like that. Well, so we can see how many times my loop is actually going to repeat, right? So my outer loop, I have 0, right? And then I add 1 to every single time the loop is done. So because my initial value is 0, and I'm adding 1 every time it's going to increase, and my final number is going to be 5 that I'm trying to approach, the values that A can be are going to be 0, 0, 1, 2, 3, and 4. So what does that indicate to me? That indicates to me that there are going to be 5 iterations of this. It's going to repeat 5 times, just like so. And I can actually do the same to my inner loop as well. So I say that my inner loop, right, if I have 0 as my starting point, and I'm going to be adding 1 every time, and my ending value of the condition is going to be that I'm approaching 4, right? Then I can say that this is going to be running 0, or B will be equal to 0, 1, 2, and 3, because it's going to repeat 4 times. All right, so now I know that this is going to repeat 4 times right here. And the reason why I did that is it's going to make it a little bit easier for us to instead of going through all 20 different asterisks, it'll be easier for us to just, to kind of understand what's happening. So the first thing I do is I'm going to be printing this out 4 times, because I know my inner loop is going to repeat 4 times. And then I print out a new line, right? And then my next iteration of my outer while loop will start, and I run it, and I get 4 again. And then, right, there's going to be another print line, and I'm going to run it again. And this is going to repeat This is going to repeat 5 times because I said that my outer loop is going to repeat 5 times, which means there are going to be 5 rows, right? So my number of rows is currently equal to the end A range, right? And my number of columns, which are over here, So my columns is going to equal to my end B range. Okay? So knowing this, now I can answer both questions. The answer to number 5 is A, right? The number of rows will be equal to A range, right? Up here, as I specified. And the number of columns will be equal to the B range, which I specified over here. And then in this question, I can circle C as my correct answer because there are 5 rows, right? 5 rows and 4 columns, just like I specified. All right, so now we get to number 7. This question is a little bit of a I don't want to say a trick question, but this is something that the College Board could do, and it could make your day very miserable. So I want you to really look at this problem again. Maybe take a second if you didn't catch it the first time, and look and notice if you see that there's anything weird here. And after further investigation, you may find that after B, there is not a semicolon. There's a missing semicolon. Because there's a missing semicolon, Java is not going to like it. And therefore, there's going to be an error when this code is run. So this is an example of where, you have to really look, especially if you have an answer choice, there will be an error. Make sure to always check for syntax errors in the actual question. It will probably save you a few points on their test or save some questions on the AP exam. And it would have saved a point possibly on this review, okay? So now number 8, which of the following are true about for loops? So there are 3 parts of a for loop header: the initialization of the variable, the Boolean expression, right, or the condition, and the increment or decrement. That's true. And then for loops can be rarely written to an equivalent while loop. That is false. It can definitely be written. In fact, always a for loop can generally be written in the form of a while loop. It will be less concise, but it can be done. And then if the Boolean expression evaluates to false initially, the loop body will not be executed at all. That's also, that's true, just like that is true for while loops. So therefore, the correct answer would be C, 1 and 3. All right, so now for number 9, and this is a very simple for loop, right? What is the output of the code below? Well, I start out with 0. 0 is less than 5, so I print out 0. And then I increment this value to 1, right? 1 is less than 5, so I print out 1. Then this changes to 2. I print out 2, 3, 4. And then when this changes to 5, 5 is no longer less than 5, so it stops running, and my output is 0, 1, 2, 3, and 4. Okay? Now I go to number 10. Which of the following output is equal to the output, or which of the following is the output of the code below, rather? So I have int a equals 2, and then I have for int I equals a minus 1, so this is really just 1, right? My condition is true. It's literally just the keyword true, right? My condition is true, and then I have I++. But there is no point in my code where I can change this condition. So because this condition is true, it's always going to run over and over and over and over and over. So my output would be that there's an infinite loop here. Okay? Now to number 11, and this is going to be one that is also a nested for loop. But if I know that I am incrementing by 1, and this is a less than, right, and not a less than or equal to, I can simply take this number as the number of times this outer loop is going to iterate. So this will be 4 times. My inner, I have a plus here, and I have a less than. I don't have a less than or equal to, and I start out with 0. So my number here is 5. Right? This is a little bit of a shortcut. So if I know my outer loop is going to iterate 4 times, and my inner loop is going to iterate 5 times, I can simply multiply these numbers together and get the number of times this code here is going to end up repeating. So in this case, if I'm printing asterisks and I print it, and I'm going to be repeating it 20 times, I will print out 20 different asterisks. Number 12 is going to be a vocabulary-based question. What is the exception raised when a loop runs infinitely? Keyword infinitely. It will be an infinite loop error, and it's more of a logic error. It's not going to... It will eventually crash your computer, but infinite loop is correct. Number 13, if a for loop executes infinitely, so if there's an infinite loop with a for loop, it indicates what problem with the header. And then you have all three of them. You have the initial value of the variable, the condition, and you have the increment. Well, if it's actually running infinitely, then it can be any of these. It can be any of the above. Your increment could be wrong. Your initial value could be different, and also your condition could be messed up. So all three of those things would have to get checked if you have an infinite loop. And then number 14, it asks the exact same question, but this time for a while loop, right? So if it executes infinitely, what is going to be the problem? One, the condition expression is not a Boolean type. If it's not, the loop's not even going to run at all, so that's incorrect. The condition expression was never changed from true to false. That is correct, right? And these are incorrect because if it's true, remember, if it's true the first time, it's just going to keep running until that condition changes to false. So it needs to change to false. And if it never changes from true to false, then it's going to be running infinitely. All right, so that concludes section 1, which is the multiple choice section. I hope that made sense. There are obviously, especially number 7, which was kind of a trick question, and then also the nested for loops, which are a bit exhausting. But otherwise, this is definitely very reminiscent of something that, you may, I don't know what your teacher will do. Your teacher may ask questions similar to this, but definitely questions like, what is the output of the code below? Those type questions may be very similar to what you could see on the AP exam, depending on, what questions you get that year or whatever they decide to do. And now we get to the free response section. And the free response section, again, is this time I've modeled it very closely to how it is going to be modeled on the actual AP exam. So I have pretty much used even the same font pretty much that they use at this point. So you can see exactly how it will look. And this will help you get prepared for that, all right? So it says, this question involves the implementation of a multiplication table generator represented by the multiplication table class. Remember, 3rd grade now, we're getting back to 3rd grade with the multiplication tables, or 4th grade or 2nd, or I guess even kindergarten if someone learned multiplication in kindergarten. I'm not really sure what people do, but I guess it varies. There's some people who learn multiplication in kindergarten. Anyway, so I don't think, generally it's going to be around 3rd grade, but you never know. Anyway, so a multiplication table shows the products of the numbers in the header of the row, right? And then the number over here on the side. So, for example, if, 11 times 10, I can do by looking at the 11 column and the 10 column, and then the intersection is going to be the product, right? It's going to be that solution that you're looking for. So this is a 12 by 12 multiplication table, right? And most people know what multiplication tables look like and kind of what they do, how there's going to be an axis of numbers on one side, an axis of numbers on the other side, and then, basically products all the way through. Okay. So, in the table above, all of the products of numbers between 1 and 12 are shown. For example, again, like I said, 9 and 8, you look for the intersection of the row 9 with column 8. And then multiplication tables are generally symmetrical in terms of axis length. However, in this case, it is possible that they won't be. So the first thing is now it shows you the class you're going to be working on completing. This is what they also do on the AP exam. They'll give you a class and they'll highlight the 2 different things that you have to do, the 2 different methods you may have to fill in. They usually tell you what it's going at the top, what the purpose of the method is, and then also the code, which is inside of your curly braces, and when you'll be completing that. So you can see here, my first method says returns the value of two numbers multiplied together. I can see that it's a private static int, so it's going to return an integer. The name of the method is multiply numbers, and it takes in two integers as parameters. So now this is a bit of a throwback to unit 2, right? And then here it says the code to be implemented in part A. Then the second is that the second method is called render table, and you'll be printing out the multiplication tables with headers to the log with the dimensions specified. You have an x dimension and a y dimension, and that will be implemented in part B. All right, so let's look at part A. Write the static method multiply numbers, which returns product. Probably should say returns the product. A little bit of a typo there. Returns the product of the num1 and num2 parameters. That's a messed up sentence. All right, so, and then I have two things that I have to follow. Number one, the function must only use loops and the addition operation to multiply both numbers. All right, and that the multiplication operator or related compound operators must not be used to receive full credit. So, you know how normally you'd multiply numbers, you do 2 times 4? Yeah, you're not allowed to do that, right? This function is literally the same thing. You're multiplying two numbers, except you have to do it using loops and addition. And while this is definitely not the easiest nor concise way that you would be doing it, the reason why I did this type of question is, first, it kind of builds connections, and also it helps you, practicing using loops. Because a lot of people forget that multiplication, right, is just repeated addition, right? And again, that keyword repeated means that, I can apply iteration to addition, right, and it can replicate what multiplication would be like. So here, what I'm trying to do is I'm trying to return num1 times num2. That's what I'm trying to return. Right? Except I have to do it using only addition now and loops. So I have to do my open and close parentheses like you would on the AP exam. They'll literally give you this header and then this blank space where you have to write stuff in there. And so the first thing I do is I have my initial number. Let's say I want to do 2 times 3, right? What I would do is I would start with 0 and then add 2 to it 3 times, right? Because it's repeated addition. I'm adding 2 3 times. So what I can do is I can say int result equals 0. So I'm creating a result variable, which I'll be returning later, which is currently set to 0. And now what I can do is I need to create a loop. So I do a for loop, because in this case, for loop will be easier because I'm working with repeating a certain number of times, right? Remember that from the last video, part 1. So I first need to create my counter in I equals 0, right? And then I say I is going to be less than my number 2, the number of times I'll be adding number 1. And then I increment I by 1, and then I have my loop. And then all I do is I do result, right? I do result plus or equals num1, just like that. And the last thing I do is I return my result, because my code asked me to return the value of the two numbers multiplied together. So that is the solution for this question. Now let me show you an example of what would happen if I put in two numbers so that you can visualize what is done here. Let's say I'm doing 2 times 4, okay? My result is initially 0, and now I'm repeating my loop a total of 4 times. And what I'm doing is my first time, right, I equals 0. Is 0 less than 4, right? It is less than 4. So it's going to run the code inside of here. So then I take my result plus equals my number 1, which my number 1 is 2. So now my result is 2. Now I increment my number 1, right? Is number 1 less than 4? It is. So I run the code in here, and I add 2 to my result. Now my index number here is going to be 2. Is 2 less than 4? It is less than 4. So then I would add 2 to my results to make 6. And then lastly, I have 3. 3 is less than 4? Yes. So I add 2 to my number. And then I increase my counter to 4. Is 4 less than 4? It is not, so my loop ends, and I return my result, which is 8. 8 is indeed 2 times 4. So that is the result. That is the correct solution. Now, if you did this with a while loop and it comes to the same result, it's also okay. A for loop, though, would be a little bit more concise for this particular scenario. So that there on the screen is the result for this particular function. And this one is much easier than the next one. All right, so B. Write the method render table, which will print a multiplication table into the log based on the x dimension and the y dimension variables, which will represent the x dimension and the x-axis dimension and the y-axis dimension respectively. Each cell in a row printed must be separated by a space. Be sure to include the header row and the header column as row 1 and column 1 respectively. The top left corner should be represented by an X. And then use the multiply numbers method above. So I need to use the method that I used above to determine the value that should be placed in each cell. And I assume that it's defined correctly. So basically, if I did something wrong, it doesn't take off points here. And so now this is an example if I set my parameters equal to 8. You see here I have my header column, or my header row. And then I have my header column right here. And then here I have solutions. Now you can see here the table does not look even due to the varying length of numbers. However, it is acceptable this way. So if I were to do 8 and 8, I would look for the eighth row and then the 8th column, and that would tell me my answer. And then here I have a example if my output here was equal to, if this was 5, if my x dimension was 5 and my y dimension was 3, it shows me what my output would look like. All right, so let's construct this particular method, right? Render table, in which I have to print out a multiplication table. This one is going to be a much more longer function, so I made it longer in terms of where I put my opening and closing parentheses, or my braces rather. So the first thing I want to do is I want to print out my header row. So that's going to be my first thing, and I'll write a comment here: print header row, right? The first thing I need to do, right, is I need to print the x. I need to print the x that's at the top left. That is over here in my example. I need to print this first before I print out everything else. Remember, I'm trying to print out my top row. And my top row is going to be an x first, and then 1 to my x dimension. Okay? So I'm going to first do system.out. And I'm going to print out an x. And I will have a space, right, so that I can, do the rest. Now that I've printed out my x, I can now print the numbers that go from 1 to my y dimension. So what I can do here is and I will do another for loop, but I'm going to be doing it a little bit differently this time. So I'm going to do for int I equals 1. This time I'm going to change my counter to 1. So initially it is 1. And instead of my condition of I being less than my x dimension, I'm going to say that it needs to be less than or equal to my x dimension. And that will allow me to have I equal to the actual last number possible, right? And then I have I++, which will increase my value of my counter. And then I have an open and close parentheses. Then in here, I will do system.out.print, and I'm going to print out I. Now remember, I can access this variable inside of my for loop, but I cannot access it outside. So I can access it inside, so I can print out I, and it's actually going to print me, it's going to print its current value inside of my loop. And that will allow me, well, let me first add a space afterward, because remember, each cell has to be separated by a space. What this allows me to do is it allows me to print my first row of my table. I print out the x, and then I print out every value from 1 to the maximum of my x dimension. Okay? And that is it. Now I've completed the header row of my actual program. Okay? Now what I need to do is I need to do system.out.print line. And so now by doing print line, I can now move to my second line. Now the last thing I need to do is I need to do a for loop for my y dimension. Because now what I need to do is I need to print out, right? I need to add lines now for every single y dimension I have. So I'm going to do for, so now this will be the table. I'm going to do for int I equals 1 again, okay? And then I'm going to do I less than or equal to y dimension this time. Y dimension. And I'm going to increase I by 1 each time. Now the first thing I can do is now I can print out the actual, the first cell here for each row, because now I'm going to be printing a row like this. I want my first item, right, to be the actual number of what row it is. So to do that, I do first system.out.print I, right? And I forgot up here to add a space. So instead of, I put it empty instead of a space. Let me just add a space there. Okay. So now this code right up here inside of my for loop, it prints out the first letter, the first number of the actual row, right? The first column number in my actual row. Now I need to print out each and every item inside of my row. And to do that, I do another for loop. But this time it's going to be for every single value inside of my x dimension. So I have a nested for loop here. For int j, this time I'll just use j equals 1, I less than or equal to x dimension, and then I increment j each time. And then what I do is I will print out, so I'll do the exact same code up here, but this time I'll print out j instead of I. I'll print out j. All right, so now what I need to do to finish off my loop is at the end of my system here, I have to do system.out.print line. So I need to print out a final line to basically, once I'm done printing out all of these items, right, which is what the inner for loop does, I need to print a new line so I can start it again. So this is the code to print out a multiplication table based on my x dimension and my y dimension. If I were to rate this particular problem in difficulty, I would give it a full 5 out of 5 probably in terms of difficulty. But the reason why I put it on here is, again, it's a good review for you to be able to try and to solve. And I definitely recommend plugging this into your favorite code editor, whether it be JGrasp or Eclipse or whatever you use for our class. We used JGrasp in our class because it did not have any autocomplete, so it's very helpful for the AP exam, especially when you have a paper and pencil and you don't have autocomplete. So it's definitely very helpful to not use autocomplete in your class because it helps you to kind of remember how to do things without always relying on that crutch all the time. But I definitely recommend putting this into your editor and to run it and to see, how things work. But this one's very complicated because it has loops and it has a nested for loop. But essentially the first part here, it prints out that header row. I start out with X and then I increase my numbers all the way, right, to the maximum of my X dimension. And then here in this part of my table, the first thing I do is I print out the number of my header row, right? And then my second inner for loop here prints out each item inside of my actual table. And then this continues on. So if I duplicate, this will continue on all the way until my table is done. And that, in the end, is how this particular function render table, the solution of render table, is supposed to be. So again, this particular prompt, if you will, to solve using code is a little bit more difficult. In fact, it's probably equal to what you'd see on the AP exam, possibly a little bit easier than what you'd see on a little bit more difficult than what you'd see on the AP exam, but this is definitely very, very, very helpful to understand loops. If you're able to do this problem, right, you'll be fine for any loop type of thing. And especially if you're able to do multiply numbers, that's good. But if you're able to do B, then you're pretty much set for the exam. And so, you need to do more practice, especially if you're not able to get this one, especially with nested for loops. If you get a little bit more practice understanding, maybe doing more practice problems. And in the future, I will be posting a lot more problems, perhaps to my Twitter, is probably where I would place it, or also on a Slack group if I decide to end up making one. But for right now, just beware of my Twitter. It's at Ajay Gandecha, which is my name. If you look at my Twitter, if you look at my description, I'll have it. Or if you just lowercase and then take my first name, last name, and put the Twitter @ sign in front of it, you'll see my Twitter. So definitely recommend going there. I will be having more practice problems in the near future, but for now, this will conclude the practice test for Unit 4 iteration. All right, so thanks for watching. If you liked it, consider liking and subscribing for more content. Unit 5 will be coming in a few days, which is writing classes. And as always, have a good day, and thanks for watching.